All right, this is part two of a series of videos on the equation of a straight line. In part one, we gave an illustration and an explanation of how the equations of straight lines come about and their significance. And then we went on and established three forms of the equation of a straight line. The first form we said is the standard form. So we said if we have an equation, or rather we've got a straight line that goes through 0c, which is called the y-intercept, and this straight line has got gradient m, then we said the equation of this straight line is going to be y equal to mx plus c, where this m is this one and this c is this one here. We said this is the standard form of the equation of a straight line. It's probably the most common or most popular, I should say. Most people that have had any study of straight lines will know that form y equals mx plus mx plus c. Then another form of the equation of a straight line that we talked about, we said this one is called the one point form. So if we know one point through which the straight line goes, and this one point is not necessarily the y-intercept as it was the case here. So the straight line goes through x1, y1, and it has got gradient m as well. Then we said there is a form of the straight line equation that we can write, which is y minus y1 equal to m times x minus x1. We said this one is called the one-point form of the equation of a straight line. Then there is a third form that we mentioned. We said this one is called the general form of the equation of a straight line. We said the general form is ax plus by plus c, where typically a, b, and c are not fractions. So if you clear the fractions and then bring everything to the one side, then you get what we call the general form. We're now going to look through some examples of how these three forms of equations can be used. First, we are going to be given some conditions, and then we'll find the equation of a straight line satisfying those conditions. And then in the second question, we're going to be given the equation. Then we are going to work things out from there. All right, so in these examples, we are going to want to find the equation of the straight line satisfying given conditions. Then we are going to leave the equation in general form. So remember, that's the general form up there. So in the first example, we have got a straight line with gradient 3. It's passing through negative 4, 3. The recommendation that we made in the video covering straight line segments, that we must always make a sketch, still applies. So even here, so whenever you are working with mathematical problems that involve shape and space, we always advise that you make a sketch of the situation. So even now we're going to make a sketch. So in A, we have got a straight line passing through negative 4, 3. So negative 4, 3 is in the second quadrant, and then we're told that this line has got a gradient of 3. So we said positive gradient means a line that's a bit like a forward slash, so that means this line is going to go through that point somewhat like that. But right now we need to find the equation. I'm going to show you two approaches of finding the equation. First, we're going to use the standard form of the equation of a straight line, which is this one here. Then we're going to use the 1-point form. So we're given this point, we're given that the gradient is 3. So what we do is starting from this equation, we straight away plug in 3. So 3x plus c. Then we need to find c. So we have already used this information. To find c, we need to use the fact that the line goes through minus 4, 3. So this is saying when x is minus 4, y is 3. So we're going to take that information, plug it in here, and then that's going to tell us what c is. So in place of y, we're going to plug in 3. In place of x, we are going to plug in negative 4. So it's going to be 3 times negative 4 plus c. So we've got 3 is equal to minus 12 plus c. If we bring 12 to the left hand side, so this is telling us that c is equal to 15. Then we go back to this equation and plug in c is 15. So y is 3x plus 15 is our equation. Now, since we want to write it in a general form, then we bring everything to the one side. I'm going to write y minus 3x minus 15 is equal to 0. All right, so that is the approach using the standard form. Then in method 2, I'm going to use the 1-point form. So the 1-point form say y minus y1 is equal to m into x minus x1. M is the gradient of the function. So m for our example is going to be 3. y1 and x1 are the coordinates of the given point. So 3 is going to correspond to y1. So I'm going to write y minus 3 m is the gradient, it is 3 as well. Then here we're going to have x minus x1, so it's going to be x minus negative 4. Then we just need to simplify on the right hand side. Minus negative 4 is the same as plus 4. We remove the brackets, so this is 3x plus 12. Then we bring everything to the left hand side, so it's going to be y minus 3x, bring 12 this side, is going to be minus 3 minus 12. So that is giving us the same equation as we found before. Both methods are equally acceptable. Right, let's go to example number B now. In B, we have got a line with gradient minus 2 on 5. So gradient is minus 2 on 5. And this line goes through 7 minus 2 passes. Seven minus 2. So let's just make a little sketch again. 7 minus 2 is going to be somewhere in the 4th quadrant. And then the gradient of this line is negative. So that means the line is a bit like a backslash. 7 minus 2 and m is negative 2 on 5. So again, we're going to start off with the standard form of the equation. So m is negative 2 over 5. Okay. Then to find c, we use the fact that when x is 7, y is minus. So we're going to plug in minus 2 this side, then minus 2 over 5 times 7 here. So this is going to be a bit involving because of the fractions. So we have got minus 2. 2 times 7 is 14. Going to have 14 over 5 plus c. So this is telling us that c is going to be minus 2 minus 14 over 5. So that's going to be minus 10 over 5 minus 14 over 5. So this is minus 24 over 5. So that is c. So then we can now write our equation. Y is equal to minus 2 over 5 x minus 24 over 5. And then in order for us to write this in general form, we need to clear the fractions. So we're going to multiply everything by 5. So we're going to have 5y is minus 2x minus 24. Then bring everything to the same side. So that is going to be our equation in general form. Then using the 1 point form, so again, so our y1 is negative 2, our x1 is 7, m is negative 2 over 5. So y minus negative 2, then minus 2 over 5 x minus 7. Okay, then in this method, at this stage, we're going to multiply, or we're going to bring the 5 to the, bring this 5 to the right hand side, and then we won't have to deal with any fractions. So maybe first, let's just note that that becomes plus 2. So of course, we advise that you do one step, one calculation per step. So if we bring now the 5 to this side, 5 times y is 5y, 5 times 2 is going to be 10. So this side we're going to be now left with minus 2 times x times minus 2 times x minus 7. Then if we remove brackets, it's going to be minus 2x plus 14. Then we bring everything to the same side. So it's going to be 5y plus 2x. Okay, looks like there is a small issue because this is going to work out to minus 4. So we need to sort out where the error was or is. All right, we have managed to locate the error. So in our earlier calculation, from this step to this step, we missed out that negative there. So if you plug in that negative, excuse me, then c becomes negative 2 plus 14 over 5. So this becomes plus, and this is going to become 4 over 5. So our c is plus 4 over 5 here, and then multiplying through by 5, it's going to give plus 4 here, and then minus 4 there. All right, and then now this is tallying with the same equation that we're getting there. Okay, now for question C, we are looking for a straight line that passes through 3 minus 8 and minus 4, 6. So let's make a sketch of this. 3 minus 8. 3 minus 8 is in quadrant number 4. The other one is minus 4, 6, which is in quadrant number 2. Minus 4, 6. So that means our straight line is going to be somewhat like that. From this rough sketch, we can see that we expect the gradient of this to be negative, because it's a bit like a it's a bit like a backslash. So this time the gradient is not given, but we're given 2 points, so we can calculate the gradient. So that's exactly what we do. So we're going to do 6 minus negative 8. So we're doing this minus this. So we are going to do exactly the same thing with the x values. So that's going to be negative 4 minus 3. 6 minus negative 8 is the same as 6 plus 8. This is negative 7. So this is going to be 14 over negative 7. This is negative 2. So m for this straight line is negative 2. Then I'm going to use the 1 point form just for this example. Now, which point do we use, this one or this one? And the answer is, it doesn't matter actually. I'm going to demonstrate that you get the same equation whichever of the 2 points you use. First of all, I'm going to use this one. So for that one, we're going to have y minus 6. M is negative 2. Then we're going to have x minus negative 4. Then x minus negative 4 is the same as x plus 4. Remove brackets, this side we're going to have minus 2x minus 8. Then bring everything to one side. We're going to have y plus 2x minus 6 plus 8 is plus 2. So it's y plus 2x plus 2 equal to 0. So we used this one. Now, if we do the same calculation using the other point, we're going to have y minus negative 8, negative 2 into x minus 3. Okay, then this one is y plus 8. Removing brackets this side, we got negative 2x plus 6. Then bringing everything to the same side is y plus 2x plus 8 minus 6. This is y plus 2x plus 2 is equal to 0. So we get the same equation in both cases. Okay, and then the next example is we've got a straight line that goes through minus 2, 9, 4, 19. So minus 2, 9, 4, 19. This is D. Minus 2, 9 is in the second quadrant. Minus 2, 9. 4, 19 is in the first quadrant. So it's definitely to the right of this point. Question is it below or above? So 419, since the y coordinate is much bigger than this one, is going to be above. Because then that gives us the sense of whether this line is upsloping or downsloping. So then if we plug this into the 1 point form, first we need to find the gradient. So let's find the gradient this side. So it's going to be 19 minus 9 over 4 minus negative 2. 19 minus 9 is 10. 4 minus negative 2 is 4 plus 2 is 6. Dividing both of them by 2, this is 5 over 3. So m is 5 over 3. So we're going to have y minus 9, if we use this point, is 5/3 x minus negative 2. Then again we bring the 3 to the right hand side just so that we don't have to deal with fractions. It's going to be 27. This becomes x plus 2. So we've got 3y minus 27 equal to 5x plus 10. So we've got 3y minus 5x minus 27 minus 10 equal to 0. Got 3y minus 5x minus 37. That is our equation. All right, so that's for examples there. We're going to give you an opportunity to try 2 examples at this point. E, let's say we have a line with a gradient 5 on 4 passing through the point -6, -1. F, you're going to find a line passing through the 2 points -5, 7, and 3, -5. So if you just want to pause the video, have a go at these 2, and then when you press play, then you will find our solutions that you can compare then with your work. All right, so we hope that you have had a go at these 2 examples now. I'm now going to scroll down to our solutions. So in E, we've got a straight line with gradient 5 on 4. So M is 5 on 4. And then the straight line passes through -6, -1. So if we just plug into the 1-point form, M is 5 on 4. Y1 is -1. X1 is -1. So that becomes Y plus 1. That becomes X plus 6. To avoid working with fractions, we take the 4 to the right hand side, and then we'll remove brackets here. We'll bring everything to the same side, and the final equation is 4y minus 5x minus 26 is equal to 0. In F, we have got a line that goes through -5, 7. -5, 7 is in the second quadrant. And then the other point it goes through is 3 minus 5. 3 minus 5 is in the fourth quadrant. So that gives us a clue that this line is going to have a negative gradient. Indeed, when we do the calculation, we find that the gradient is -3/2. Then we plug this in the 1-point form. So M is going to be -3/2. X1 is 3. Y1 is -5. Do the necessary simplifications, and our final answer becomes 2y plus 3x plus 1 is equal to 0. Looks like we're going to have to extend this to a part 3 because this was actually number 1. So then in part 3 we're going to look at number 2. So in number 1 we were finding the equation of a straight line. Number 2 we're going to be given the equation of the straight line, and then we'll be finding other particulars of that given straight line equation. Thank you for watching. Hopefully this has been useful. Please do subscribe so that you can get notified whenever we post new materials. Thank you.